Hi, welcome to the channel. Here I post challenging math problem videos. If you like this video, then give it a thumbs up and subscribe to the channel. So without further delay, let's start. Today we have a problem which is based on the maxima minima. Now the problem says if alpha be a parameter where alpha is sigma from k to infinite, k equal to 1 to infinite sine to the power 2k pi by 6, and gx be a function which is 2 to the power alpha x plus 2 to the power alpha into 1 minus x. So based on this information, we have to find this values of gx, maximum and minimum values of gx. So one way of doing this problem is using calculus. The second way of problem is I am proposing a different method using AMGM inequality to solve this problem. Okay, so let me write first this alpha as sigma k equal to 1 to infinite sine to the power 2k pi by 6. So if we expand this, we can write this as sine to the power, so putting k equal to 1, so sine square pi by 6 plus sine to the power 4 pi by 6 plus sine to the power 6 pi by 6, and so on. It is going up to infinite. So this is nothing but simply gp. So the sum of the gp is first term a by 1 minus r. So first term is sine square pi by 6, and this common ratio is also sine square pi by 6. So in the denominator we have cos square pi by 6, and in the numerator we have sine square pi by 6. So it is nothing but tan square pi by 6. Okay, now this is alpha. So pi by 6 means 1 by root 3, 30 degree, and tan of 30 is 1 by root 3. So tan square means 1 by 3. So we get the alpha value. Now coming to the second portion of this problem, that is gx. So let's say gx is given as 2 to the power alpha x plus 2 to the power alpha into 1 minus x. Now you can differentiate and find the critical point and check for the first derivative using first derivative test or second derivative test. You can find this maximum and minimum values. So I am not going to that part. I am using the AMGM inequality. Okay, let's say this is two uh, parameters, that is a and b. So let's say this is a, so this is a and this is b. So using AMGM inequality, we know AM is greater or equal to GM. Okay, now this 2 to the power alpha x into 2 to the power alpha into 1 minus x divided by 2. So AM of this term is greater or equal to GM. So GM is 2 to the power alpha x into 2 to the power alpha into 1 minus x to the power half. Okay, now this is nothing but gx and gx by 2, and this is 2 to the power alpha by 2, because this alpha x will get cancelled. Okay, so our gx value is 2 into 2 to the power alpha by 2. Now putting a value of alpha, so we have okay, so let's say 2 to the power, this is 1 plus alpha by 2. So alpha is 1 plus 1 by 3 means 1 by 6. So this is 2 to the power 7 by 6. So this is gx. So this is the minimum value. Okay, so this is the minimum value of gx. So this is the first option. You see, this is the first option. So this option is correct. Now for the maximum value, so to check with this, what we can do is we have to plot this graph. Let's say you must know, let's say fx be a graph of say a to the power x. Okay, so just a minute. So the a to the power x graph is like this. Okay, and if let's say hx be a graph of a to the power minus x, so a to the power minus graph is like this. It is nothing but the mirror image around this y-axis. So this is a to the power minus x, and this will cut at this point. So if I add this, means a to the power x plus a to the power minus x, we get the graph of this is okay. So this is the graph of a to the power x plus a to the power minus x, which will get a minima point at this point. So using this concept, we draw this graph of g to the power x. Okay, because here this, let's say we are going to plot this gx graph. Okay, so gx graph means this will go to this. Okay, why I am shifting to this point? Because this x, if gx is 2 to the power alpha x plus 2 to the power minus alpha x, so this graph will be passing at minima will be at x equal to 0 point. Okay, but this graph has shifted to 1 minus x side, so the graph will be shifted to the slightly in the right hand side of the x-axis. So at what is this point? So this is nothing but the midpoint of this two. So x equal to 1 minus x, so x equal to half. So this is the minima point at which x equal to half, at which this attains its minima. So this is half, and the minima is this. We have already calculated the minima, that is 2 to the power 7 by 6. Okay, now we have to check the maxima point. Okay, so let's, and what we are given here is g is going from 0 to 1. Okay, to all real values. So this is 0 point. Okay, now put g as 0. So g0 equal to 2 to the power alpha 0, that means 1 into 2 to the power 1 minus 0, that is 2 to the power alpha. Alpha means 1 by 3. So 2 to the power 1 by 3. So this is the first point at which this is 0 comma 1 plus 2 to the power 1 by 3, and now put g at 1. Okay, so g at 1 means 2 to the power alpha by 3 plus 1. So this is, let's say this is 1 point. So this is 1 comma 2 to 1 plus 2 to the power 1 by 3. So which means from graph it is clearly seeing that this is an increasing function from x equal to half to x equal to 1, and decreasing function from x equal to 0 to x equal to half. So which means it attains two maxima. So multiple maxima is correct. So which means option 3 is also correct. Okay, and the maxima point of gx is 1 plus 2 to the power 1 by 3. So this is also correct, and minima is only at 1 point. Okay, so it is given here, it is that minima is more than 1 point, so this is wrong. So option A, B, C, all are correct. Okay, so this is all for today. See you tomorrow.